For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. Since the dawn of humanity, the night sky has been our window onto a larger reality. For our ancient ancestors, the heavens above were evidence that there is something out there. Out of reach, yet somehow connected to life on Earth. As they gazed upward from night to night and year to year, our ancestors noticed changes in the sky and wondered what those changes might foretell about their own destinies. Some of those changes were easy to spot, like the nightly drift of the constellations from east to west. Or the monthly spectacle of the moon marching through its phases. And there were more fleeting changes, like colorful displays of aurora borealis. Or the chance appearance of a bright comet slicing across the heavens. But no change attracted as much attention from our ancestors as the complex dance of a few brilliant objects moving around among the constellations. They looked like stars, but by their motions it was clear these objects were somehow different. They were called the Wanderers, or in Greek, the planets. For centuries, astronomers puzzled over the motions of these planets, trying to decipher the clockwork nature of our universe. But it would take the invention of the telescope to show us how special the planets really are. When the telescope arrived, it offered a new kind of window on the universe, one that transformed the planets from lights moving in the sky into distant worlds orbiting around the sun. In other words, the telescope helped us understand that we are part of a solar system full of planets, asteroids, comets, and more. But there is also a limit to how much of the solar system any telescope can show us. Which is why what happened next was the most exciting development of all.
CMO.
Loaded and verified.
Roger, thank you. Will you transfer it to the enable queue? Copy that.
Roger.
In the 1960s, a new kind of technology appeared that was destined to show us the planets like never before. Thanks to spaceflight, it was no longer going to be a matter of getting better windows on the distant planets. Now our windows were moving to the planets and giving scientists back on Earth a taste of what it would be like to visit alien worlds. The earliest space voyages to reach beyond Earth were aimed at our nearest neighbor, the Moon. And when a Soviet space probe named Luna 3 became the first to image the Moon's hidden far side, it was clear a new age of exploration had begun.
5, 4, 3, 2, 1. Fire command, fire command.
Suddenly, every planet was a potential destination. Before long, space probes were crossing the great ocean of interplanetary space and sending back their close-up glimpses of Mars, Venus, and the sun-baked surface of Mercury. By the 1970s and 80s, the U.S. space agency, NASA, was ready to reach even farther, to the distant outer planets. The most celebrated mission of this time, Voyager 2, managed to visit 4 giant planets in a row, including Jupiter, Saturn, and Uranus, before finally reaching Neptune in 1989. More recently, a second wave of missions has given us powerful new views of many of the planets and allowed us to see the solar system from a fresh perspective. In some cases, that perspective means more detail and more complexity than we could ever have dreamed of. Like the detail in these cloudy swirls in Jupiter's turbulent atmosphere. Or these broken and refrozen icebergs on the surface of Jupiter's moon, Europa. In other cases, spacecraft have revealed more history than we could ever have hoped for. Here, in a crater punched into the barren Martian desert, we find ancient layers of rock jutting from the crater's rim. Geologists have read these layers like the pages of a novel, and the story they tell speaks of long-vanished water that once bathed an alien landscape. Collectively, the rich new views and precious data that are coming to us from so many planetary missions make it clear our solar system features astonishing diversity. Yet the evidence is also telling us these very different places in the solar system have a common origin. According to the best available evidence, some 4.5 billion years ago, our sun was born out of a vast cloud of interstellar gas and dust. Today, the Hubble Space Telescope can see the same process at work throughout our Milky Way galaxy. What appears to us as a gorgeous nebula of glowing gas is really a star factory, and our sun came into being in just such a place. But the sun was not created in isolation. As matter swirled together to form our newborn star, a small fraction of that matter ended up in a disk of gas and debris spinning around the infant sun. As material in the disk coalesced, it formed planets, moons, asteroids, and comets. And like different children born to the same parents, each member of our solar system family has its own distinct characteristics. One of the big questions to come out of planetary science is how could all of these solar system objects have started from the same basic ingredients, but followed such very different pathways? As far as we know, only one of those pathways led to Earth, a planet capable of supporting life and keeping that life well protected for the billions of years it took for us to finally show up and start wondering about the solar system. The poet T.S. Eliot wrote, "We shall not cease from exploration." And the end of our exploring will be to arrive where we started and know the place for the first time. When it comes to exploring the solar system, Eliot's words are literally true. Every planet, every moon, every asteroid we visit has a different story to tell us. And by putting together all those stories, scientists hope to understand how we came to be here, in our place, in our time. These are questions that touch us all, and the journey to answer them has now begun. Of all the destinations that await explorers in our solar system, none could be more terrifying or more beautiful in its alien grandeur than this hellish domain of searing, writhing, and dancing fire. This is the vast and volatile powerhouse whose explosive outbursts can reach across millions of kilometers of space to rattle our tiny planet. But it is also the fountain of creation, upon whose energy our entire living world and civilization critically depend. It is our sun. Even in ancient times, our ancestors understood that without the sun's warmth and light, life as they knew it would not exist. For them, the sun was nothing less than a god. Today, we know the sun is a star, just one among the hundreds of billions that populate our Milky Way galaxy. But for us, the sun is special. In our solar system, there are 8 planets, several dozen moons, hundreds of thousands of asteroids, and possibly trillions of comets, But there's only one sun, and it's 1,000 times more massive than all the rest of the solar system combined. The gravitational pull of all that mass is what keeps everything in its orbit. So no matter where you are in the solar system, it's the sun that takes center stage. 4 centuries ago, the astronomer Galileo was certain the sun, not the Earth, was at the center of our solar system. He would later be tried for heresy for defending this radical idea. Galileo was also one of the first to point a telescope at the sun, which led him to another surprising discovery: sunspots. These are dark patches that appear on the sun from time to time and seem to drift across its blazing surface. In time, astronomers discovered that a subtle pattern governs the appearance of sunspots. Over a cycle lasting approximately 11 years, they grow increasingly more numerous on both sides of the sun's equator, spreading northward and southward until they cover all regions of the solar surface. And then, just as they reach their peak, they diminish, and the cycle begins anew. Sunspots offer a visible clue that the sun is not just our cosmic light bulb, but a complex and dynamic system. Even before Galileo's time, there were clues that there is more to the sun than meets the eye. The most obvious appears every time the moon passes directly in front of the sun, causing a total eclipse. This wispy white glow that stretches outward from the eclipsed sun is called the solar corona. It is the sun's searingly hot outer atmosphere, a region where ionized gas is energized to a temperature that is far higher than at the sun's surface. And like sunspots, the corona is always changing. These clues suggest that the sun releases its energy in complicated ways. But for generations, scientists were stumped trying to understand where that energy comes from in the first place. Then came the atomic age, with an unexpected side effect. The discovery of nature's hidden nuclear forces gave scientists the insight they needed to understand what makes the sun shine. Like most stars in the universe, the sun is mainly made of hydrogen gas. At the sun's surface, that gas is about 5,600 degrees Celsius, hot enough to glow with a bright yellowish light. But deep inside the sun's core, the temperature rises to millions of degrees. And under these extreme conditions, hydrogen atoms can combine to form helium. The energy released in this reaction gradually works its way outward from the sun's core through overlying layers until it is released into space. Only a tiny fraction of the sun's total energy falls onto our world, but over the eons, it has been remarkably steady. And this has allowed life to evolve and flourish on Earth. Yet, there are also plenty of reminders that the sun is not always so benevolent. Scientists have long known about giant explosions on the sun called solar flares that can wreak havoc with power and communication systems while producing dazzling displays of aurora borealis. To better understand the sun's changeable nature and its influence on Earth, scientists have learned that they must venture into space where the sun can be monitored around the clock and observed in ways that are not possible from the ground. This has allowed astronomers to study the way features shift and change on the sun's rotating surface over a long period of time. A less direct way of studying solar activity from space involves using a circular disk to block the sun's light. This creates an artificial eclipse inside the spacecraft, making it easier to follow dramatic changes in the sun's corona. For years, the SOHO spacecraft has made good use of this method. Here, SOHO looks on as a comet swoops in near the sun and is greeted with a blast of high-energy particles. In some cases, a vigilant spacecraft can even catch the occasional trespasser. Here we see the planet Mercury transiting across the sun's fiery disk. These views from space reveal an incredibly dynamic sun, intimately connected from surface to corona by a powerful but invisible force: the force of magnetism. In fact, the sun is the most powerfully magnetized object in the solar system. The reason for this is that the sun is not a solid body, but a turbulent, electrically charged fluid. It is the motions of that fluid that ultimately generate the sun's tangled and ever-changing magnetic field. This field frequently pokes through the solar surface and forms long loops out into space. The bases of these loops are where we find sunspots, because that's where material that would normally be turning over and sinking back down into the sun's interior is temporarily held at the surface and allowed to cool and darken. The loops and twists in the sun's magnetic field can store vast quantities of energy. Occasionally, that energy is released with astonishing speed and violence. The result is a solar flare. On October 29, 2003, SOHO captured these views of one of the most powerful solar flares in history. It begins with a large, magnetically active region rolling into view on the sun's left-hand side. As the sun rotates, the region gradually moves to the center, where it faces the spacecraft and us. With a sudden flash, the flare erupts, followed by a burst of static as high-speed solar particles pummel SOHO's camera. SOHO survived, but a powerful solar flare like this can easily knock a satellite out of commission. Another hazard often associated with solar flares is a coronal mass ejection. It begins as a huge release of magnetically energized particles from the sun's corona. The particles shoot across space at high speed. When they encounter Earth, the particles cascade down onto the atmosphere, producing brilliant aurora around the North and South poles. What the age of space exploration has taught us is that the sun is not an isolated and distant part of our solar system. Rather, the sun is an environment that Earth travels through. And it's not just Earth that experiences this. The sun's magnetic fields and the flow of particles that stream off its surface travel well beyond our world and all the other planets of our solar system. It ultimately creates a giant bubble that separates all of us from the flow of interstellar material that permeates the galaxy. With the sun, we not only live with a star, we live within one. Billions of years ago, each planet formed from the same primitive mix of atoms that went into creating the sun. Since then, the planets have all gone their separate ways, each with its own unique story to tell. But there is also an underlying connection, because in the end, We are all children of the sun. For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. To the human eye, our universe is all about light. It's the sign that matter is present in stars, in galaxies, and in great expanses of glowing gas. But despite its beauty, this colorful realm of gas and stars is not a place where life can exist. Life as we know it is too fragile to survive the searing temperatures that make atoms of gas glow in space. What life needs is a very different kind of place. One not simply made of swirls of gas, but of something solid. Life needs a rocky planet. Without planets made of rock, there would be no chance for life as we know it. But simply having a solid place to stand is no guarantee that life will gain a foothold. We can see this in our own solar system, where there are many different kinds of rocky worlds. First in line is Mercury, a small and mysterious planet that is alternately baked then frozen as it slowly rotates in the sun's glare. As the nearest planet to the sun, Mercury's daytime surface temperature can reach more than 420 degrees Celsius. Yet on the planet's night side, where heat is quickly radiated into space during long months of darkness, the temperature can drop below -180. For decades, Mercury's one and only visitor was the Mariner 10 spacecraft, which flew past the planet 3 times, starting in 1974. It gave us our first close-up look at Mercury's baked and battered surface. But Mariner 10's view was incomplete, capturing less than half of the planet during its few brief encounters. So, in 2004, NASA launched a new mission, Mercury Messenger, whose goal is to orbit Mercury and provide the first comprehensive survey of its geological features and mineral composition. At first glance, Messenger's images seem to be showing us a desolate and moon-like world. The surface is rough and heavily pockmarked with craters from billions of years' worth of meteorite impacts. But first impressions can be deceiving. Although Mercury is only slightly larger than our own moon, its gravity is more than twice as strong, which means Mercury is much more massive. In fact, Mercury is so heavy, it may be almost entirely made of metal. Some scientists have speculated Mercury began its existence as a much larger planet whose exterior was mostly shattered away in a giant collision, leaving behind only a thin rocky mantle surrounding a large metallic core. Whatever happened, it's clear Mercury once bubbled and rumbled with the internal heat from a tumultuous formation. Numerous features suggest a world that was volcanically active in the distant past. This view shows a landscape with multiple ripples underlying the more recent impact craters. The ripples, frozen in time, reveal where vast pools of lava once flooded the planet's surface. In this image, false colors help to highlight Mercury's complex history. Here, the bluish areas represent an ancient terrain that was gradually buried by debris, shown in orangey red. The debris is made of material kicked up by large crater-forming impacts blasted into Mercury's surface. There are also giant cliffs and escarpments threading their way among the craters. These cliffs are a common feature on Mercury. They may have formed when the planet's giant metal core cooled and contracted, causing the overlying rock to wrinkle like a planet-wide version of shrink wrap. Messenger's first views of Mercury reveal the bare bones of a rocky world. There is nothing here but a solid surface that hasn't changed very much over eons of geologic time. While Mercury may provide the beginnings of a stable platform, it is far too hot and barren to be anything other than an empty stage. To transform a dead planet into a living world, more ingredients are needed. First and foremost, an atmosphere. Lack of atmosphere is not a problem for this planet. Enigmatic Venus is the second rocky world from the Sun. Permanently shrouded under a dense, cloudy atmosphere, Venus was hidden from astronomers for centuries, despite being the nearest planet to Earth. Now we know that Venus's atmosphere is a toxic brew composed of carbon dioxide with clouds rich in sulfuric acid. The carbon dioxide is brutally effective at trapping the sun's energy, heating up the planet to a staggering 460 degrees Celsius. That's even hotter than Mercury, although Venus is twice as far from the sun. And Venus's atmosphere is incredibly dense. The air pressure at the planet's surface is so high, it would easily crush a human astronaut to death. These conditions are so extreme that to date, we have only fleeting glimpses of Venus's surface taken by a handful of Soviet landers, none of which survived more than 2 hours. With a planet so inhospitable to spacecraft, scientists have had to come up with another way of exploring Venus's hidden terrain from a safer distance. Radar can penetrate the planet's thick blanket of clouds and bounce off the rock below, providing a detailed look at a bizarre and dramatic landscape. What these images reveal is a world shaped by volcanoes, and one that could still be volcanically active today. The apparent lack of impact craters, so different from what we see on Mercury, is a strong indication that Venus's surface is young and may be continually evolving. Scientists now suspect that in the past, Venus may have been much more like our own planet. But as its atmosphere heated up, it lost something vital that makes Earth special in our solar system. It's water. Here on Earth, oceans have played a key role in keeping our planet suitable for life. Not only do oceans moderate the climate and help keep the atmosphere stable, they lubricate Earth's rocky surface, so its internal heat is mainly channeled into moving the continents slowly around the planet. Without water, heat would build up and burst out in vast and deadly lava flows, as may have occurred on Venus. Most of all, oceans provide a liquid medium where complex molecules can interact. The preconditions scientists now believe are necessary to turn mere chemistry into biology. Earth is our best example of the true potential of rocky worlds. It seems that when a planet has all three ingredients, a solid surface, an atmosphere, and oceans of liquid water, it can foster something new, the emergence and evolution of life. But while life has come to dominate Earth with its richness and complexity, it has also buried its tracks, making it difficult to understand how our planet came to be the way it is today. That is one big reason why scientists are so keen to explore the rest of the solar system, now that the technology is available to do so. It is here where we may find the clues that will tell us what Earth was like before life appeared, and how it all happened. It may be that only when we reach across the ocean of space to distant rocky shores can we truly understand our own identity. In all of nature, there is perhaps no view as haunting and beautiful as a full moon. It is both familiar and mysterious. A part of our world, yet a world unto itself. Today, we look across at our nearest neighbor and find not a mirror image, but an alter ego. While Earth looks lush and colorful, the moon is a study in black and white. While Earth's surface is shaped by water and air and abounds with the sounds of life, the moon's is silent and still. Here, no rivers run and no winds blow. All that exists are memories of events long past, memories of our solar system's violent beginnings and Earth's own tumultuous history. For billions of years, the moon has been the ultimate silent partner, keeping watch over Earth from above and keeping its secrets to itself. That's not very satisfying to humans, which explains why every civilization in history has its own myth about how the moon came to exist. But only after the invention of spaceflight did we finally get the real story.
30 seconds forward. 40 feet down, 2.5. Picking up some dust. Contact light. Okay, engine stop.
To date, over 50 spacecraft have now flown past, orbited, or landed on the moon with eye-opening results. At long last, our silent partner is beginning to reveal its fascinating story. When viewed up close, the moon's surface is inundated with impact craters. They form when small asteroids collide with the lunar surface at high speed. The energy from a large impact is enough to liquefy and hollow out a crater many times the size of the original impactor, while throwing debris thousands of kilometers in all directions. Over billions of years, our planet has experienced just as severe a beating. But on Earth, impact craters are eroded away or buried in sediment over time. On the moon, they simply accumulate, leaving a vivid and detailed record of the hazardous nature of our solar system. By carefully counting craters, it's possible to tell which parts of the moon's surface formed first and which came later. For example, the dark patches on the moon we can see even from Earth are clearly younger than the surrounding bright areas. In the past, astronomers named these dark patches Maria, Latin for seas. But when explored up close, it's clear there's never been any water on these alien shores. Rather, the Maria are vast, low-lying plains of volcanic rock. Long ago, these plains were covered in hot lava that spilled out from the moon's interior and flooded over an older landscape. Because they are richer in iron than other parts of the moon, they appear darker in contrast. One of the big achievements of lunar exploration has been the complete mapping of both sides of the moon's surface. The moon rotates in perfect time with its orbital period, with one side constantly facing Earth. Surprisingly, the two sides of the moon turn out to be quite different from one another. While the side that faces Earth is covered with Maria, the moon's far side exhibits much less contrast. It's an ancient, rugged terrain interrupted only by a few larger impact sites. This peculiar two-sidedness has to do with the moon's crust, which is substantially thicker on the far side. Scientists now suspect that billions of years ago, when the moon's internal heat forced lava upward, it found a shorter route to the surface on the moon's near side. But how and when did those circular plains form in the first place? The surprising answer comes from the lunar samples that were brought back by Apollo astronauts. The samples show the lunar Maria were once the sites of enormous impacts, many of which date back roughly 3.9 billion years. This is very early in the solar system's history, when space was more crowded with debris than it is today. Nevertheless, the evidence now suggests something exceptional happened 3.9 billion years ago, as though a storm of asteroids suddenly swept through the inner solar system, pummeling all of the planets as well as our own moon. The devastating barrage left the moon plastered with giant circular scars. On Earth, it was much worse. The impacts would have vaporized oceans and liquefied large sections of our planet's crust. Though no animal or plant was living on Earth at the time, it is possible microbial life had already made its debut. When the bombardment came, perhaps only those microbes that were dwelling far down near deep sea vents survived to repopulate the ancient Earth and become our distant ancestors. The idea that the Moon and Earth were both heavily bombarded is one of the big results to come out of the samples that astronauts returned to Earth. An even bigger one is the astonishing revelation that the Moon itself may have once been the product of a giant collision. This theory is that early in our solar system's history, an object as large as Mars once collided with Earth and dealt our planet a staggering blow. The collision immediately spewed out vast amounts of debris. Much of this material found itself in orbit around Earth, where it eventually coalesced to form a single large moon. As incredible as it seems, this giant impact scenario offers the best explanation for some of the moon's more puzzling features, including its apparent lack of an iron core. Ironically, the moon's destructive birth may have also been crucial to maintaining Earth as a cradle of life, unique in our solar system. The moon's presence helps to stabilize the tilt of Earth's axis, preventing climate swings that would be devastating to life and civilization. Because of the way it formed, the moon's past is intimately linked with our own. Without it, the evolution of life may have taken a very different course. In fact, if it weren't for the moon, we might not even be here at all.
Houston, Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
Exploring the moon has given us a remarkable window into the past. But the moon may also be our gateway to a long-term future in space. In the US, China, and elsewhere, efforts are now underway to return humans to the lunar surface. It is an ambitious goal, but it's also a stepping stone along the road to more distant destinations. Exactly where the next human mission will land is still an open question. But one thing is certain: there is no shortage of interesting places on the moon where scientists would love to visit. The lunar South Pole would surely be at the top of their wish list. Here, the sun never shines on the floors of some craters. Forever in shadow, these dark craters should be cold enough to trap water vapor and maybe even form lunar ice. Although the moon is dry, the water vapor could come from comets colliding with its surface. Scientists have now confirmed the presence of hydrogen in many south polar craters, strong evidence for the presence of ice. If there is enough ice, it could provide lunar explorers with much-needed water. But finding and retrieving the ice will be a challenging task, as it would involve venturing into perpetually dark places. Today, the moon presents us with an intriguing and exciting destination in space, and a staging ground for even more daring explorations on Mars and beyond. Perhaps more than any other location in the solar system, It is the moon that tells us we live on just one world among many. And if we are determined enough, we can one day visit them all. For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. When everything is exotic and strange, the familiar beckons. And when it comes to exploring the solar system, the familiar calls us to Mars. Although it is clearly an alien world, Mars is also a planet with landforms we immediately recognize. It is a world with deserts and dunes, cliffs and canyons, a landscape we can imagine ourselves exploring firsthand, on 2 feet or on 6 wheels. But familiarity doesn't make Mars any easier to understand. After scrutinizing its landforms from orbit and sampling its soil and rocks from the surface, we have become better acquainted with Mars than any other planet in the solar system apart from our own. But our questions about its present state and complex history have only multiplied, including the biggest question of all: did life ever exist here? Mars is not like Earth, where life is abundant and obvious. It's also not like the Moon, where there's really no chance for life at all. Mars is somewhere in between, and so it can help us define where life can and cannot exist. When we journey to Mars, we journey to the Borderland. Mars's borderland status is nothing new. Astronomers have been musing about the potential for life on the red planet for more than a century. When the first grainy close-ups of Mars were radioed back in 1965, scientists were surprised and a little disappointed. The images showed a barren and cratered surface, much more like the Moon than any place on Earth. Apparently, the red planet was the dead planet, and any notion of spotting life on the surface, even primitive life, all but vaporized. But first impressions can be deceiving. As follow-up missions arrived in the late 60s and 70s with increasingly better cameras, it became clear Mars is a far more interesting and diverse planet than anyone had realized. Yes, there were impact craters, but there were also signs of a colossal geologic history. Giant volcanoes, larger than any on Earth, were found towering over the Martian plains. The largest of all, Olympus Mons, rises to a height of 24 kilometers from its base, 3 times higher than Mount Everest, making this not just the tallest peak on Mars, but the tallest in the solar system. Such an impressive structure must have arisen through widespread eruptions of lava that poured out across the surface again and again, possibly over billions of years. Olympus Mons sits atop a giant bulge known as Tharsis that protrudes from Mars and makes it a distinctly lopsided planet. Ultimately, it led to a spectacular splitting of the planet's crust and the creation of this giant canyon, Valles Marineris. The proportions of Valles Marineris stagger the imagination. It is more than 10 times longer than Earth's Grand Canyon, and 4 times as deep. Today, the best images of Mars come from the Mars Reconnaissance Orbiter, an orbiting spacecraft that carries the most powerful telescope ever sent to another world. Capable of resolving details on the surface as small as a dinner plate, it has given us an unprecedented look at Mars in all its splendor. From exquisite sand dunes to tracks left behind by Martian dust devils. But perhaps the most interesting views are the ones that suggest water once flowed on Mars. Deep inside Valles Marineris, it appears as if there were layers of sediment deposited in shallow Martian lakes, long before the giant canyon formed. Even the shape and orientation of the terrain suggests water once flowed on Mars. These hints of a watery past grow much stronger as we cast our view beyond Valles Marineris to a series of large but empty channels leading away from the Tharsis Bulge toward the low-lying regions further north. Although they dried up long ago, these valleys must have been created by vast outflows of moving water that cut across the Martian landscape, spilling out into the northern plains. In some cases, these channels measure 100 kilometers across and carve their way through thousands of kilometers of terrain. Their discovery drastically changed scientists' view of Mars. Today, Mars is far too cold and its atmosphere far too thin for liquid water to persist on the surface. Yet these channels, which bear all the marks of catastrophic flooding, suggest that Mars once had water in abundance. If so, what caused the release of this water, and where did it go? The answer to the first question probably lies with the Tharsis Bulge. It now seems likely the intense heat that led to the formation of Mars's giant volcanoes also forced the release of vast quantities of water stored in the Martian crust. At first, the water flowed underground, but then it broke out onto the surface, creating the features visible today. Across Mars, there are other signs that water may have flowed billions of years ago. Strong evidence from orbiting spacecraft now suggests much of this water lies frozen underground in the form of permafrost near the Martian poles. Certainly, the Martian polar regions are different from the rest of the planet. Not only do both the north and south poles of Mars have visible caps of frozen carbon dioxide that grow and shrink with the changing seasons, both possess a smaller underlying cap of water ice that is never warm enough to melt away. The surface at the poles also looks different. A substantial quantity of ice mixed in with the rock in these locations means cliffs and crater walls tend to slump, giving them a smooth, rounded look. One of the most exciting recent developments has been the discovery of small gullies running down the sides of craters and canyons all across Mars. They look suspiciously as though they were carved by groundwater, seeping from the cliff faces and running downhill. Yet these features are so small, they must be recent. Otherwise, the steady deposit of wind-blown dust would have obscured them. Could there really be liquid water periodically bubbling to the surface on Mars? If so, the implications for life are enormous. After more than 4 decades of concentrated exploration, there's no doubt that Mars has a rich history, which certainly included liquid water and may have once included life. Furthermore, there are hints that Mars continues to be an active planet today. It is not yet a dead world, at least in the geologic sense. It is still a borderland. All of this is impetus to explore Mars further. But there are limits to what can be seen and sensed from space. To answer the question of whether Mars is a living world, we must touch, taste, and smell it. These goals can only be achieved by taking our explorations down to the very surface of Mars. Like the great voyages of discovery centuries ago, the journey to another world is fraught with danger.
Atmospheric entry on my mark.
And when it comes to landing on Mars,
5, 4, 3, 2, 1, mark.
It is always the final moments.
Phoenix now 2 minutes and 25 seconds past the entry point.
When the peril is greatest.
80 meters. 50 meters.
Come on.
Constant loss space detected. Altitude 40 meters. 30 meters. 27 meters. 20 meters. 50 meters. Standing by for touchdown. Touchdown signal detected. Landing sequence initiated.
It is hard enough to design a machine that can land itself on Earth. But to do it on another planet, where humans have never set foot, where knowledge of changing conditions is scarce at best, to have no margin for error between a safe landing and total catastrophe, and to do it in a place that is so distant, even a simple call for help would take several minutes to reach Earth, that is a challenge indeed. But that is precisely what must be done to touch another world. So far, 6 landers have set down safely on Martian soil, and they have transformed our understanding of the planet as only first-hand experience can. Scientifically, these missions were designed to discover the geologic history of Mars, but they also carry a powerful implication about the future. It's not just the ancient past we seek when we land our probes on Mars, but a new dawn in space exploration. A red dawn. In 1976, two NASA spacecraft named Viking 1 and 2 became the first to establish a beachhead on Mars. And the view was electrifying. Geologists were immediately reminded of deserts they had visited on Earth. Once the Viking landers set to work, the similarities began to fade. While the results did not completely rule out life on Mars, they suggested that any life that managed to survive here would need to be sheltered underground or in some other impossible-to-reach location. It would be more than 20 years before another successful attempt was made to land on Mars. In 1997, NASA's Mars Pathfinder landed at the mouth of the Ars Valley, a vast channel that looks like it was carved by running water. The landing site was surrounded by broken and tumbled rock. Boulders were slanted in a downstream direction, all signs of an ancient and violent flood. The star attraction of the mission was a small rover that rolled off the lander and trundled up to nearby rocks to analyze their compositions. It was a vivid demonstration of what was needed to really begin tackling the mystery of Mars: a set of wheels. In early 2004, two rovers named Spirit and Opportunity landed safely on opposite sides of Mars. Each embarked on its own motorized trek across the red planet's surface. From the start, it was obvious that the two rovers had landed in very different settings. Spirit had been sent to Gusev Crater. Evidence from orbit suggested it was an ancient lake where standing water may have left its mark in the soil chemistry. But when Spirit opened its electronic eyes, it found a barren plain littered with volcanic rock. Meanwhile, Opportunity scored an early triumph. It was sent to Meridiani Planum, where remote sensing had spotted hematite, an iron-rich mineral that on Earth is often associated with water. Meridiani turned out to be a flat, nearly featureless plain, but miraculously, Opportunity landed in a small crater with an exposed rock outcrop. For the first time, scientists would be able to sample rock on Mars in the place where it formed. What Opportunity found, after wheeling up to the outcrop, exceeded everyone's wildest expectations. The rock was layered and contained ample evidence that it formed in a watery environment. It also contained hematite in the form of tiny spheres, nicknamed blueberries, which grew by precipitating out of water and were later exposed as the rock weathered away. But the best was yet to come. Back on Gusev Crater, after investigating the terrain near the landing site, scientists sent Spirit rolling towards a set of distant hills nearly 4 kilometers away. It would take 3 months to reach the hills and many more to climb them, but eventually Spirit reached the top and radioed back a sweeping panorama. In the years that followed, Spirit descended to the other side of the hills, surviving 3 Martian winters and eventually discovering home plate, the remains of a volcanic vent where hot rock once made explosive contact with water. Things were also going well at Meridiani. Once Opportunity set out across the plains, it discovered an even larger rock outcrop, whose layers read like a geologic history book. The story it told was of a place that once had been wet, but with highly acidic water, while at other times there was no water there at all. After nearly 2 years more of roving, Opportunity arrived at the edge of Victoria Crater and recorded one of the most spectacular vistas in the history of Mars exploration. High overhead, the newly arrived Mars Reconnaissance Orbiter was there to record the moment from space, spying the tiny rover perched at the crater's rim. The journey of the Mars rovers has been a scientific adventure unlike any so far in our exploration of the Red Planet. Rather than showing us Mars in an isolated spot for a brief window of time, they have shown us Mars over many years and many kilometers, including places where water once flowed. Next, scientists wanted to know about the state of water on Mars today. Compared to the Mars rovers, the Phoenix lander was a modest mission, but with an ambitious goal: to become the first spacecraft to touch water on Mars. Scientists expected to find that water locked in a frozen state just below the surface of Mars's polar regions. Here, the landscape is dominated by low mounds with trough-like boundaries. These mounds are caused by the expansion of ground ice, forcing the soil upward. After a bit of digging with its robot arm, Phoenix exposed something white just centimeters below the surface. It was ice, the first direct link to a watery past on Mars. Phoenix landed in the low-lying northern plains of Mars, an area that may once have been a Martian ocean. Although Phoenix could not confirm this, it found the soil here is alkaline, similar to what might be found in seawater on Earth. What we've learned from all these missions is that Mars was a water world, and still is today, although that water is hidden from view. As for what that means for life on Mars, that's a question for future missions. But in a sense, all of these missions are already paving the way for life on Mars. Human life. The landers and rovers we build could be the leading edge of a new wave of exploration that might one day take astronauts to the Red Planet. If so, the human story on Mars has already dawned. For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. In our solar system, gravity is destiny. It is what sets one world apart from another and puts different planets on vastly different tracks. This fundamental truth begins with the sun, a giant blazing ball of hydrogen gas. The sun keeps shining because the force of gravity squeezes the matter in its core together until it is hot enough to generate nuclear reactions. Gravity also built the planets from the matter that swirled around the infant sun. In the beginning, most of that matter was in a gaseous state. But near the sun, it was too hot for gravity to hold on to the gas. So the planets that formed in the inner solar system were small and rocky. Farther away, it was a different story. In the outer reaches of the solar system, it was always cold enough for gas molecules to stick together and form ice. Billions of years ago, that ice gathered into bigger and bigger chunks until gravity took over, pulling in vast quantities of material and setting the stage for planet making on a giant scale. Here's what happens when you get enough gas together to make a planet. Jupiter is the colossus of our solar system. Beneath its swirling clouds, there's enough room to fit 1,000 Earths. Jupiter is big, too big to be a solid body. Instead, its interior is mostly liquid hydrogen, the lightest element in the universe. This hydrogen ocean is well hidden beneath Jupiter's turbulent clouds. Because Jupiter is liquid, it can spin on its axis at high speed, much faster than Earth. One day on this mammoth world lasts only 10.5 hours. This fast spin generates high-speed winds in Jupiter's atmosphere, giving the planet a striped appearance. Somehow, Jupiter's rotation also powers the Great Red Spot. A giant, swirling storm, larger than the entire Earth, that has been raging as long as astronomers have had telescopes to watch. The spot has a deep structure that penetrates many tens of kilometers, like an open window into Jupiter's atmosphere. Jupiter's visible cloud tops are made of ammonia, but scientists have not yet discovered what chemical pigment gives the Great Red Spot its distinctive color. Other storms come and go on Jupiter. This unique view, made of many separate images, shows the atmosphere of Jupiter as it would appear from somewhere above its south pole. Over time, the spots move and sometimes collide like giant ships on a stormy sea. But none have lasted as long as the Great Red Spot. The poles of Jupiter are also where we find intense aurora caused by solar particles trapped in Jupiter's powerful magnetic field. Like giant-sized versions of the northern lights on Earth, they glow brightly in ultraviolet light. Jupiter is bigger than all of the other planets combined and more dynamic, and for this reason, it is mesmerizing to watch. But there is another place in the solar system where gravity has outdone itself in creating a spectacle of stunning and otherworldly beauty. Centuries ago, astronomers were enchanted by the discovery that Saturn, the most distant planet that was known to the ancients, is encircled by what appears to be a set of narrowly divided rings. And as telescopes grew in power, so did the grace and grandeur of Saturn's rings. As these views from the Hubble Space Telescope reveal, the rings may start out at a wide angle, but eventually narrow to a thin plane, almost disappearing when the planet's equator lines up with Earth. It is because of observations like this that we know the rings of Saturn cannot be as solid as they look. A solid ring would quickly become unstable and collide with the planet. Instead, the rings must be made of trillions of icy particles, ranging in size from snowflakes to giant boulders, all guided by the gravity of Saturn and its moons. In 2004, scientists were given their best chance to learn the secrets of Saturn's rings when the Cassini spacecraft made a close pass of the rings before putting itself in orbit around the planet. As Cassini raced by, scientists trained its cameras across the ring plane, capturing one snapshot after another of the detailed patterns within the rings. These wave-like ripples are caused by the gravity of Saturn's many moons, which act on the ring particles to create shifting patterns of density, while opening up gaps which are kept free of material. In some cases, these gaps are patrolled by small moons, which shift the particles with their gravity and give the rings their sharply sculpted boundaries. Here, a newly discovered moon, only 7 kilometers across, is spotted making waves in the rings on either side of a narrow gap. Cassini has also studied the elaborate pattern of kinks in Saturn's narrow F ring. These kinks are created by the gravity of 2 moons, Pandora and Prometheus, that shepherd the ring particles and keep them on their narrow track. Among the strangest phenomena Cassini has witnessed in Saturn's rings are these fleeting dark spokes that seem to race around the rings much faster than the ring particles themselves. They are made of fine grains of dust, probably electrically charged and swept up in the motion of Saturn's magnetic field. Saturn is alive with electromagnetic energy, and like Jupiter, its poles are ringed with bright, dancing aurora. But in other respects, Saturn's polar regions look very different than Jupiter's. Here, Cassini gives us our best view yet of a strange hexagon centered on the planet's south pole. The hexagon is made of clouds and shaped by fierce winds, but the origin of its unique geometry remains a mystery. Cassini has revealed Saturn so beautifully that it is now one of the best imaged planets in our solar system, despite its great distance from Earth. Yet with each new image, Saturn continues to surprise and amaze us. This remarkable image shows us Saturn eclipsing the Sun, a view we cannot see from Earth. It is a heavenly image, even a poetic one, made even more touching by one other tiny detail. Buried in the rings, far off in the background, is a small bluish speck. Not a faint star, but a planet. It's Earth. How small we are in the solar system, but how great our reach as we send our cameras far and wide to bring us news from the lords of gravity, our solar system's largest planets. Saturn. To the ancient astronomers, it was the end of the line, the last stop before the stars. It turns out Saturn is merely the farthest planet the human eye can see. It's far, but it's not where the solar system ends. Once the telescope was invented, we discovered there was a lot more to our solar system than meets the eye. There's Uranus, Neptune, and the weird case of a planet that's not really a planet, Pluto. But even through the most powerful telescopes, these worlds remained remote and mysterious. To probe the solar system's real outer limits, you need a spacecraft. In 1977, Voyager 2 began an epic journey that would make space history. To date, it is the only spacecraft to visit planets beyond Saturn, starting with Uranus in 1986. Uranus's most obvious feature is its striking aquamarine color. This is the result of a methane atmosphere. Methane absorbs light from the red part of the spectrum, while blue light is reflected back into space. But while Uranus is unlike any planet closer to the Sun, it is not unique in the solar system. After traveling onward 3 times farther from the Sun than Saturn, Voyager 2 finally reached what is now the farthest known planet, Neptune. As with Uranus, it found a blue world, but one with an atmosphere that seemed more active, with bright white clouds made of ice crystals and dark oval storms. Compared to Jupiter, Uranus and Neptune are small, not nearly large enough to be big balls of liquid hydrogen and helium. On the other hand, they are still far larger than Earth, too large to be solid, rocky planets like our own. So Uranus and Neptune are fluid worlds, but they are mainly made of gases that freeze at low temperature, including water, methane, and ammonia. For this reason, they are called ice giants. Although you don't see any ice when you look at these planets, they must have formed from countless icy fragments that once filled the outer reaches of the solar system. Like Saturn, both Uranus and Neptune are encircled by rings, but their rings are narrow and dark. So dark, in fact, they resemble the color of charcoal and must be rich in carbon. They may be the last remnants of small moons that were disrupted by gravity and pulverized into tiny fragments. The rings are just one element in a story that suggests this quiet and dark outer region of the solar system was once witness to scenes of great violence. Uranus, for example, is nearly tilted on its side. Instead of spinning like a top, it rolls like a bowling ball, first pointing one pole and then the other almost directly at the Sun. Its rings and moons are oriented the same way, giving Uranus the appearance of a giant bullseye in space. This peculiar tilt was almost certainly the result of a giant collision long ago in the planet's history, perhaps near the time it was forming. Other signs of past collisions can be found on Uranus's bizarre icy moon, Miranda, which looks like it's been blasted apart and put together again the wrong way. Its craggy cliffs are among the highest in the solar system. Meanwhile, Neptune's largest moon, Triton, orbits Neptune backwards. How this happened is not easily explained, but it is likely Triton did not begin as a moon of Neptune. As Voyager 2 discovered, Triton is only slightly smaller than our own moon and larger than Pluto. It may have once been an independent citizen of the outer solar system that wandered too close to Neptune and was captured, perhaps after colliding with some of Neptune's other moons. Today, Triton's icy surface is crisscrossed with markings that hint at a geologically active past. The surface is made of ice, frozen water, but it's cold enough to be as hard as rock and has a strange texture resembling the skin of a cantaloupe. Much of its southern hemisphere, the only part seen by Voyager, is covered with a methane and nitrogen frost. dark streaks on the ice are probably the sooty residue from gas geysers breaking through the icy surface. The streaks are parallel, suggesting that winds blow fast in Triton's thin atmosphere. If Triton was captured by Neptune, then it is our first opportunity to see up close an entirely new class of objects. These are small, icy, and moon-like bodies that escaped becoming part of a larger planet when the solar system formed. Now, they silently patrol the vast border region of the solar system, starting just beyond the orbit of Neptune and extending far into the deep space beyond, where the distant sun is no more than a bright star. Pluto and its moon Charon are surely members of the same family. When it was first discovered, Pluto was hailed as the 9th planet. But its tiny size and unusual orbit suggest it is not exactly a planet, but something else. In recent years, many more objects have been spotted at a similar distance, including Eris, found in 2003. Eris is even larger than Pluto. Rather than making it the 10th planet and potentially adding many more to the list, astronomers demoted Pluto instead. Now Pluto and Eris are grouped with similar objects in a newly created category, dwarf planet. The region where Pluto, Eris, and other dwarf planets live is known as the Kuiper Belt. As many as 70,000 separate objects larger than 100 kilometers may ultimately be found here. And they are clearly not all alike. For example, the Kuiper Belt object known as Sedna is redder than Mars. Its color may be due to chemical changes that occurred during billions of years of cosmic rays striking organic molecules trapped in Sedna's icy surface. Sedna's orbit stretches out far beyond the Kuiper Belt, suggesting other hidden members of the solar system may still be lurking just out of sight. Tiny and remote, the inhabitants of the Kuiper Belt appear as little more than dots, even in the world's most powerful telescopes. Yet these objects are among the most interesting to scientists because they can tell us a story about the early days of our solar system when the giant planets were still forming out of icy building blocks like these. In 2006, to satisfy our curiosity about these most distant members of the planetary family, NASA launched New Horizons. No spacecraft has ever traveled so far to meet its primary objective, and the journey has only just begun. Now, New Horizons is well on its way to the outer limits and is scheduled to reach Pluto in 2015. When it arrives, it will be moving too fast to be captured in orbit. Instead, it will fly past both Pluto and Charon, radioing back images and data, and showing us for the first time what a dwarf planet is really like. At its closest, New Horizons will see details as small as 50 meters across on Pluto's icy surface and look for signs of past geologic activity. After Pluto, New Horizons will move on to other targets in the Kuiper Belt, including some which may not have even been discovered yet. If it succeeds, scientists hope the most distant and mysterious region of our solar system will finally seem a little more familiar. When New Horizons finally shows us Pluto, it will mark the end of an era. Pluto is no longer officially called a planet, but it represents the last type of solar system object that we have yet to see up close. Without Pluto, our story of the solar system and its history is missing an important chapter. New Horizons will write that chapter, and for the first time, give us a glimpse of the entire book. The whole solar system in all its diversity, from the blazing sun to the dark depths of the Kuiper Belt. Somewhere in that book is the story not just of rock, gas, and ice, but the story of chemical complexity and life itself. For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. There are more than 100 moons in our solar system. The vast majority of them orbit the two largest planets, Jupiter and Saturn. Collectively, they run the gamut from small to large, cold to hot, and quiet to active. Could it be that somewhere in that range of possibilities, we will find a hidden haven for alien life? Most of the moons that orbit Jupiter and Saturn are quite small, but a few are so large and complex they could easily be considered planets. For more than 300 years, there was almost nothing astronomers could say about these intriguing places. Thanks to spaceflight, that's no longer the case. In 1979, Voyager 1 and Voyager 2 sailed past Jupiter's 4 largest moons with their cameras rolling. The pictures they radioed back reveal that each moon has its own distinct character and a range of features unlike anything seen before. The biggest surprise of all was Io, the innermost of the 4 moons. Its rocky surface is a mottled and sulfurous mess. Unlike our moon, there are no craters on Io. It's as though they are being erased by some mysterious agent. The explanation came when Voyager 1 spied something unusual protruding 300 kilometers from one side of Io. It was a fountain of ash spewing from a large volcano. Since that discovery, it's now become clear Io is the most geologically active world in the solar system. Io's surface is one vast lava flow, with more than a dozen active volcanoes towering over the sulfur-rich landscape. The gravitational pull of Jupiter and some of its other large moons creates a tug-of-war inside Io, which generates vast amounts of heat. While this makes for a dynamic surface, it is not particularly hospitable to life. Jupiter's outermost large moon, Callisto, couldn't be more different. Callisto's battered face is saturated with ancient impact craters, suggesting not much has happened here since Callisto formed. But looks can be deceiving. The most recent data suggest there could be a zone of salty water somewhere deep below Callisto's surface of ice and rock. Whether life could survive in such a hidden environment remains an open question. Meanwhile, on Ganymede, we find more obvious signs of a geologically active past. Ganymede is the largest moon in our solar system and one of the strangest looking. Part of its surface is as old as Callisto's, dark and heavily cratered. But the dark areas are fractured by a more recent terrain made up of parallel grooves and ridges. Exactly how these grooves and ridges formed is still a big mystery. It is clear Ganymede has a warmer interior than Callisto. In the past, that warmth may have risen up through Ganymede's interior and forced sections of its surface to drift apart, just like the continents on Earth. Because of its heat, Ganymede's interior has likely separated into layers, starting with an iron-rich core at the center, a surrounding mantle of rock, and a thick layer of ice on top of that. As with Callisto, there is evidence on Ganymede for an ocean of salt water somewhere below the surface. This is exciting news because the right combination of heat and water may provide the conditions necessary for life on Ganymede. Such life forms would be cut off from the sun and the surface environment. But like the creatures that live around deep sea vents in Earth's oceans, it might survive on chemical energy. This tantalizing possibility won't be tested anytime soon. If Ganymede has an ocean, it's at least 200 kilometers below its frozen surface. A better opportunity for exploring the ocean of another world may exist on Europa. At first glance, Europa seems like the least interesting of Jupiter's moons because its surface is so flat and smooth. Its lack of dramatic relief, like mountains or large craters, might be an indication that water isn't far below. Europa is crisscrossed with a network of cracks that suggest its icy crust has opened up from time to time, letting a watery slush spill out onto the surface. In one area, scientists have found what appear to be icebergs that cracked and floated apart like rafts before the surface refroze. Some of the cracks on Europa have a darker and more reddish hue than the rest of the surface ice. This could mean that the underlying ocean is rich in sulfur compounds and perhaps organic molecules. Indications are that in some places, this ocean may be less than 10 kilometers from the surface, possibly within reach of a future attempt to drill down and explore the marine environment of another world. Today, Europa's ocean is high on the list of locations where scientists are eager to search for alien life. The surfaces of Jupiter's moons may conceal many mysteries. But on Saturn's giant moon, Titan, even the surface is hidden from view. Titan is the only moon in our solar system with a substantial atmosphere, and it shows. When Voyager 1 arrived at Saturn in 1980, it found Titan shrouded by a thick orange haze. This haze is like a photochemical smog produced when sunlight reacts with methane in Titan's atmosphere. It would be a full generation before scientists had their next chance at Titan. When the Cassini mission arrived at Saturn in 2004, it used a high-powered camera equipped with an infrared filter to penetrate the veil of Titan's thick haze. What Cassini found was even stranger than expected. A surface divided into mysterious light and dark regions, resembling ancient coastlines. Cassini also bounced radar signals off of Titan, confirming that the moon's surface is solid, with unusual landforms like ice volcanoes and wind-blown dunes. After several more passes of Titan, Cassini's radar made an even more exciting discovery: a series of dark patches that were perfectly flat, resembling the surfaces of small lakes. Scientists were eager for more direct evidence of potential fluid flow on Titan. They found it in dramatic fashion when Cassini dropped a probe into Titan's cloudy atmosphere. After the probe deployed its parachute and slowly descended, it radioed pictures back to Cassini. As soon as the probe emerged from the clouds, it began to see exciting details that looked suspiciously like they had been carved by a flowing liquid. Then, to everyone's surprise, the probe survived its impact and sent back one final spectacular image. It showed chunks of ice, clearly rounded by fluid flow, like rocks in a stream bed on Earth. On Titan, it's so cold that water is like rock, but methane, which is a gas here on Earth, can rain down from Titan's atmosphere and flow as a liquid over the surface. Methane is a building block for the kinds of complex molecules that led to the emergence of life on Earth. And that means if Titan has an internal heat source, like some of Jupiter's moons, it could also be harboring its own ecosystem deep below the surface. One thing is clear: Titan and Jupiter's moons are no longer sideshows to the planets they orbit. Together, they have become the main motivators in our exploration of the outer solar system. Here on planet Earth, it's easy to take water for granted. Water covers 70% of Earth's surface, and its presence is essential for life as we know it. Farther away, in the dim reaches of the outer solar system, water plays a different role. Around Saturn, water is everywhere. With temperatures near minus 180 degrees Celsius, it's far too cold for water to exist in a liquid state. Here, water remains frozen solid, so solid that it doesn't just cover worlds, it makes worlds. When we get to Saturn, we discover ice is the main ingredient in building moons. In fact, Saturn is surrounded by an entire family of icy moons that the Cassini mission has now revealed in spectacular detail. By exploring these frozen worlds, scientists hope to reveal an ancient story, not just about Saturn, but about the entire outer solar system. This is certainly the case with Phoebe, the first of Saturn's moons that Cassini encountered up close. Just 200 kilometers across, Phoebe is too small and its gravity too weak to pull itself into a sphere. When Cassini sailed past Phoebe, it found a surface rich in carbon, with deep craters exposing layers of bright white ice lying just below. Overall, Phoebe is darker and contains more rock than Saturn's other icy moons. This suggests it did not form near Saturn, but in the Kuiper Belt, beyond Neptune. The objects inhabiting this zone are ancient, the original building blocks of the outer solar system. It now appears Phoebe is an escapee from that region and only later captured by Saturn and turned into a moon. This moon is giving us a sneak preview of what we'll find at much further distances from the Sun. 4 times closer to Saturn and 4 times larger than Phoebe, Iapetus is a very different kind of moon. It is 80% ice, but its most distinctive feature is its strange two-tone shading. While one side of Iapetus is extremely dark, the other is whitish gray. This color difference also corresponds to a significant temperature difference. On average, the dark side is 15 degrees warmer than the light side. Scientists now suspect that dark material, possibly blasted from the surface of Phoebe, may have fallen down onto Iapetus long ago. The side that received the dust absorbed more of the sun's energy, and the ice there began to sublimate, leaving behind grains of dust and rock that would darken the surface even further. Meanwhile, the vaporized ice resettled onto the other side of Iapetus and around its poles, creating the look it has today. Even stranger is a long ridge Cassini discovered running along the equator of Iapetus, giving it the appearance of a walnut. In places, the ridge is 13 kilometers high. The forces that created this bizarre feature are not well understood, but it likely happened when Iapetus was spinning more rapidly than it is now and had more internal heat shaping its surface. Moving even closer towards Saturn, we find Hyperion, a misshapen object with a strange honeycombed surface. Hyperion is so irregular in shape and appearance, it is probably just a fragment from a larger moon that was destroyed in a collision. It may not even be solid, but a loosely packed pile of rubble. Measurements by Cassini reveal Hyperion is more than 40% empty space. Signs of ancient collisions are visible everywhere on Saturn's moons, including Rhea, Dione, and Tethys. At first glance, this trio of round moons could be mistaken for identical triplets. Each one is more than 1,000 kilometers across and carpeted with impact craters from billions of years ago. But they are also variations on a theme. Each of the three has its own distinct features, suggesting a more complex and diverse history. For example, this giant canyon called Ithaca Chasma wraps around Tethys like a waistband. It may have formed long ago when the icy interior of Tethys froze and expanded, forcing its crust to stretch apart at the seams. Looking at Dione from afar, scientists long wondered about a series of wispy white lines running across its surface. Now Cassini has revealed the lines are the bright faces of steep cliffs formed when Dione was repeatedly fractured by internal forces. But the biggest surprise came from Rhea. Cassini found indirect evidence this moon is surrounded by a dark, dusty ring, making Rhea the only moon anywhere in the solar system with a ring of its own. While most of Saturn's icy moons were likely once geologically active worlds, which later cooled and grew dormant, at least one seems to have forgotten to fall asleep, and the implications are enormous. Enceladus is only 500 kilometers across. Under ordinary circumstances, an object of this size should be too small to retain heat for billions of years. But Enceladus is nowhere near ordinary. Here, Cassini spotted vast geysers of water vapor shooting outward from a region near its south pole. The vapor carries fine grains of dust, which escape into space and form a diffuse ring along Enceladus's orbital path around Saturn. Looking down at the surface for clues, Cassini has revealed a strange and puzzling sight. Enceladus is scored with long, deep gouges, nicknamed tiger stripes, from which the geysers are thought to emanate. The stripes are surrounded by fresh ice, which suggests that somewhere below the surface, temperatures are high enough to melt ice and hold liquid water under pressure before venting it into space like a tea kettle. No one yet knows exactly how Enceladus does this. One important clue from Cassini is that Enceladus has more rock and metal than many other of Saturn's moons, and so perhaps it is being warmed by a combination of radioactive heating from within and strong tides produced by Saturn and its other moons. Even more exciting is the presence of organic molecules near the tiger stripes. When this is combined with the likelihood of liquid water, it appears Enceladus may have all the ingredients necessary for life. For a tiny moon at the leading edge of the icy solar system, this is an astonishing revelation. To call the icy moons of Saturn strange is an understatement. These odd little worlds are utterly unlike Earth, but understanding how they formed and evolved is an important goal for scientists. Why? Because if there are so many icy moons in our solar system, there must be countless others out there among the stars. Whenever one of those moons is warmed up enough to melt the ice into water, there exists at least the potential for life. And perhaps our best chance to answer the age-old question, are we alone? For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. Once, it seemed the space between Earth and the stars was empty, except for the moon and a few planets. Once, it seemed the solar system was a benign place where life, once established, could develop in peace. Once, it seemed we would only ever be able to touch distant worlds by going there. But now we know sometimes those worlds come to us with devastating results. Earth is by no means alone. The vast corridor of Earth's orbit around the Sun is also crisscrossed by asteroids of varying size. The largest asteroid of all is Ceres. At nearly 1,000 kilometers across, Ceres is just big enough for the Hubble Space Telescope to see its rotation and make out a few blurry surface features. Ceres is no threat to Earth. Like hundreds of thousands of other asteroids, it is safely confined to the asteroid belt. This zone between the orbits of Mars and Jupiter is full of rocky debris left over from the birth of our solar system. But sometimes, even the slightest gravitational nudge can send asteroids drifting out of the belt directly across Earth's path. But asteroids are not the only hazards we have to worry about. Comets can be seen coursing through the solar system like guided missiles, trailing brilliant tails of dust and gas behind them. Although they are made of ice and frozen gases rather than rock, comets move so fast that a direct hit from one could release even more destructive energy than an asteroid strike. This was vividly demonstrated in 1994, when comet Shoemaker-Levy 9, after breaking up into several pieces, slammed into the atmosphere of Jupiter. It gave the solar system's largest planet a series of black eyes so large they could easily be seen by the Hubble Space Telescope orbiting Earth. For centuries, astronomers thought of the solar system as an orderly place where the planets, including Earth, quietly went about their business. Today, we realize the solar system is really more of a cosmic shooting gallery full of asteroids and comets that could threaten life on Earth. That's why exploring these objects is not just a quest for science, but a question of survival. Today, we can still find scars where violent collisions rattled our planet long ago. On Earth, wind, water, and glaciers have erased most of the evidence of ancient craters. Not so on the Moon. Here we find a surface almost entirely covered in craters, preserving the record of a violent bombardment that has accumulated over billions of years. One of the most prominent and recent lunar craters is Tycho, which formed about 100 million years ago. At that time, scientists suspected a collision in the asteroid belt may have sent a wave of rocky debris heading our way. One piece hit the Moon, forming Tycho. Another piece struck Earth, wiping out the dinosaurs and changing the history of life on our planet forever. Our first real look at the asteroid belt did not come until the 1990s, when the NASA Galileo spacecraft made close passes of 2 asteroids on its way to Jupiter. The first, named Gaspra, is only 18 kilometers long. In contrast, the asteroid Ida is over 3 times larger, and it came with an extra surprise: a miniature asteroid orbiting around it like a moon. These early glimpses set the stage for the first dedicated mission to visit an asteroid. Eros is 35 kilometers long and one of the largest Earth-approaching asteroids. And though it is not currently on a collision course with Earth, it presents the perfect opportunity to study up close the kind of asteroid that could one day pose a threat. Unlike a planet, which has uniform gravity at all points on its surface, the irregular shape of Eros means its gravity varies greatly from point to point. It is also spinning rapidly, tumbling through space. Orbiting such an object is no small feat. Despite this formidable challenge, NASA's Near-Shoemaker spacecraft made detailed maps of the surface of Eros and measured its mineral composition. It found Eros is loaded with rock and metal, with a density similar to Earth's crust. As the mission neared its end, controllers brought the spacecraft closer and closer, expecting it to eventually crash land onto Eros. To their astonishment, the spacecraft survived the landing and managed to transmit images of its final descent to the surface. Getting a spacecraft to reach out and touch an asteroid is a tall order, but doing the same with a comet is an even taller one. Comets originate in the distant outskirts of the solar system, in a region called the Oort cloud, well beyond the reach of any spacecraft or telescope. Only occasionally does a comet sweep into the inner solar system, where the sun's heat warms its icy surface, forcing it to spew vast amounts of gas and dust. In 2004, the Stardust spacecraft took a perilous journey to Comet Wild 2 to see it up close and capture a few particles streaming from its surface. Stardust showed us a tiny world, utterly different from anything seen before in the solar system. It is riddled with circular depressions, resembling craters, but with steep walls where gas could be venting into space.
Quite a trail. Near spec has a great view.
Safe on the ground.
Stardust eventually traveled back to Earth with a capsule containing samples of the comet's dust. Some of the dust grains appeared to predate the solar system itself. If so, they offer a direct window into the ancient nebula that created the Sun, planets, and all life on Earth. Meanwhile, the Deep Impact mission took a different approach. Before arriving at Comet Tempel 1, the spacecraft split into two pieces. One piece headed straight for the comet, smashing into its nucleus and raising a plume of material into space. The other part flew by to witness the event and analyze the pristine material ejected by the sudden explosion. Coated in a fine dusty powder, the comet's icy interior is rich in organic compounds, precisely the kind of matter that may have once jump-started life on Earth. There is an irony in these results. Our interest in comets and asteroids is motivated partly by the danger they pose to life on Earth. But it's quite possible that without comets and asteroids and the organic materials they bring, life might not have even started here in the first place. Like the planets, the comets and asteroids are unique and teach us something about our own place in the universe. That's the upside to living in a shooting gallery. It may be a bit scary out there, but it's never dull. For explorers in search of all that is strange and different, our solar system holds many rewards. In its sweeping vistas, the cosmos supplies unending variety. Rendered from the most basic ingredients: ice, metal, gas, and rock, the planets and moons have become nature's laboratory, where over billions of years, the laws of physics and chemistry have yielded masterpieces of astonishing complexity and beauty. It inspires the imagination, leading us to wonder if all we have seen so far could be repeated again and again in countless solar systems across the universe. Once astronomers realized the Sun is just one star among billions and the Earth just one planet, it was natural to assume other worlds existed beyond our solar system. But finding those worlds is a technical challenge of the highest order, and it has taken nearly 4 centuries since the invention of the telescope to do it. In fact, the first concrete evidence other planets exist didn't come from finding the planets themselves, but from finding the places where planets are born. Peering across 1,500 light years, the Hubble Space Telescope zooms in on the Orion Nebula. It is a giant stellar nursery where stars are forming by the thousands. The brightest shine with an intensity greater than 200,000 suns, lighting up hydrogen and other gases, producing a dazzling and colorful spectacle. But deep in the nebula, Hubble can also see what earlier telescopes could not. These tiny, tadpole-like shapes are infant solar systems under construction. Some look dark in contrast to the glow of the surrounding nebula. That means they contain dust as well as gas. It is in these dusty cocoons where planets are most likely to form. If it's happening there, then it is easy to imagine the same thing going on throughout the universe. If so, there must be countless solar systems out there waiting to be discovered. Using a device called a coronagraph, Hubble can block the bright light of a nearby star to probe the space immediately around it. In some cases, this has allowed the Space Telescope to spy the faint reflected light coming from a disk of dusty debris that surrounds the star. Some disks are seen face-on, others edge-on. Their presence is another favorable sign for planet hunters, because the dust they contain is generated by the collisions of asteroids or comets orbiting around young stars. And where comets have formed, it's likely planets have formed too. When applying this method to the bright star Fomalhaut, Hubble finds not just a disk of dust, but a ring. The fact the region inside the ring is relatively dust-free may indicate most of it has gone into building planets. These views offer tantalizing hints that planets must exist around other stars. But pinpointing those planets more directly requires a different strategy. If a star has a planet orbiting around it, gravity will pull on the star, causing it to wobble back and forth. Although this wobble is slight, in some cases it can be measured from Earth, which tells astronomers where there are planets, how far they are orbiting, and how massive they could be. Once astronomers perfected this technique in the 1990s, they began to see evidence for planets around many nearby stars. The real surprise is how different these planets are from anything we know in our own solar system. Although most are comparable in size to Jupiter, many are also closer to the stars they orbit than Mercury is to our Sun. Astronomers have dubbed these new planets hot Jupiters. The discovery of hot Jupiters came as a complete surprise. Although astronomers expected other solar systems might be somewhat different than our own, no one imagined a difference so extreme. Despite all the variety we have uncovered in our own solar system, the range of possibilities beyond the solar system appears to be far greater. As technology has improved, so has our ability to detect signs of smaller planets. And now, for the first time, planets just a few times more massive than Earth are beginning to turn up. The best way to understand what these super-Earths are like is to catch one passing in front of the star it orbits, like a miniature eclipse. Because the planet blocks a small fraction of the star's light when this happens, it's possible to measure its size as well as its mass. This can tell astronomers whether the planet is dense, containing lots of rock and metal, or more like an ocean world with a thick layer of water or ice.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine start, 1, 0, and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
To find Earth-sized planets like this, NASA has launched the Kepler spacecraft. Its mission is to stare at more than 100,000 stars for more than 3 years, waiting for their light to momentarily dim as planets cross in front. Some of those planets will be gas giants like Jupiter, but it's expected at least a few will be Earth-sized. By spotting these Earth-sized worlds, Kepler will be identifying the targets for future exploration by giant observatories in space. These follow-up missions will be vital, since they will probe the worlds that Kepler discovers for signs their atmospheres contain water or oxygen. This will help distinguish worlds like ours that may support life from worlds like Venus, which are similar in size and mass but completely sterile. Working toward this goal, astronomers are now improving their ability to directly capture the light of distant planets with existing telescopes, and they have succeeded. Returning with the Hubble to look at Fomalhaut with its dusty ring, they have even spotted a planet there. It has moved over a 2-year period, which confirms this tiny dot is not a background star, but a real planet. The planet is estimated to be no more than 3 times the mass of Jupiter, but it orbits Fomalhaut from a distance that is more than twice as far as Pluto from our Sun. This is not a planet where we expect to search for life, but with a distance of only 25 light-years from Earth, it could be one of the nearest worlds to our own solar system, and perhaps the destination of a robotic mission centuries in the future. The number of planets that have been seen directly is growing fast. Meanwhile, more than 300 planets have been found indirectly, nearly 50 times the number in our own solar system. The last 15 years have seen a revolution in our ability to find and study planets beyond our solar system. The next 15 could be even more exciting as Kepler and its successors try to zero in on planets like Earth and then hunt for signs of life on those worlds. The glorious cosmic vistas we've been granted by our spacecraft explorers and orbiting telescopes carry a message. In a universe as vast and incredibly diverse as this, there are many possibilities for life, but no guarantees. Until we find other civilizations like our own, we have no way of knowing how rare we are, or what limitations there may be to our future in the galaxy. We stand on the threshold of a new age of exploration, perhaps the greatest in human history. Now, more than ever, we need to recognize the most astounding planet we've ever encountered in the universe is the one we call home. In the ongoing exploration of our universe, every journey begins with the eye. Only the eye can travel to the stars and beyond, far outpacing the meager reach of any human astronaut or probe. Chasing the ancient light of distant galaxies back to the dawn of cosmic history. In this epic journey of discovery, no eye been more revealing and more awe-inspiring than the Hubble Space Telescope.
Start moving out. Copy, P3.
We're stalling minus 0.05 at 100.
The Hubble is not the largest telescope ever built, but it is the first large telescope ever to fly in space. This unique vantage point, high above the blurring effects of Earth's atmosphere, is the perfect perch for exploring everything from nearby planets to distant galaxies. Unlike telescopes on Earth, the Hubble can't be maintained and improved on a routine basis. Astronomers can't just drive to the Hubble to give it a tune-up. Instead, the telescope depended on visits from the space shuttle and its crew to make repairs and install new cameras. This is not an easy task, and missions to the Hubble have been among the most challenging and exciting in the history of human spaceflight. And then, on February 1st, 2003, disaster struck. The space shuttle Columbia was lost, taking the lives of 7 astronauts. Columbia's mission was not related to the Hubble, but its loss was to have a profound impact on the Space Telescope. After the accident, the remaining space shuttles were grounded, which postponed a 5th and final mission to bring new cameras and replacement parts to the Hubble. Two years later, even with new safety measures in place and the shuttles heading back into orbit, the Hubble repair mission was officially off the schedule. The reason was human safety. the Columbia disaster demonstrated how dangerous a space shuttle mission can be. Hubble's supporters were deeply disappointed. Without human support, it seemed Hubble's great eye on the universe would close forever. The telescope would slowly shut down and, in time, come crashing back to Earth. But scientists asked NASA to reconsider its decision. Flight engineers began working on scenarios that would involve one shuttle going to the telescope with another one ready on the launch pad in case of a problem. And by late 2006, with confidence in the shuttle program restored, NASA was ready to try to save the Hubble. The job would not be easy. During the years that the shuttle was grounded, the Hubble was showing signs of age. Its cameras were malfunctioning. Batteries and gyroscopes that were essential for powering and pointing the telescope were failing too. As engineers began to visualize the sequence of repairs that would be needed to restore the telescope to its full operations, it soon became clear that this would be the most ambitious mission to the Hubble ever attempted. A giant pool with a full-sized mock-up of the Hubble was used to simulate the weightlessness of space. Meanwhile, Hubble's new parts were brought out of the clean room and readied for launch. They included a pair of new cameras designed to transform the space telescope and image the universe as never before. The Wide Field Camera 3 is a versatile multi-wavelength detector capable of imaging distant objects across a broad spectrum of colors. Also on deck was the Cosmic Origins spectrograph, designed to use the light of distant sources as a way to probe the large-scale distribution of matter throughout the universe. Finally, on May 11, 2009, the rescue mission was underway.
7, 6, 5, 4, 3, 2, 1, and liftoff on Space Shuttle Atlantis. Final visit to enhance the vision of Hubble into the deepest grandeur of our universe.
Bypass across the board, Scooter, no action.
Houston now controls.
Houston Atlantis for Star Tracker.
Scooter, go ahead for Star Tracker.
We see that star approaching from the east.
Hey, that's terrific news. I guess the last time we've seen Hubble up close was March of '02.
From Houston Atlantis, 200 feet.
No previous servicing mission had ever demanded so much of astronauts in such a short time.
Houston Atlantis. Hubble has arrived on board Atlantis with the arm.
By now, it was more than 7 years since someone had visited the telescope, and the Hubble was badly in need of attention.
Coming out. Yeah, I'm just looking out the window here, and it's an unbelievably beautiful sight. Amazingly, the exterior of Hubble, an old man of 19 years in space, still looks in fantastic shape.
Installing the wide field camera was challenging but straightforward.
Counterclockwise, 2.
The new camera was built to fit neatly into the space left by its predecessor.
Look good? Looks good to me. I definitely got it. Excellent.
The Cosmic Origins spectrograph fit into another space, previously taken up by a device once used to correct the built-in flaw in Hubble's optics.
Coming in now.
Okay. And another inch down.
One more inch down.
This one feels
All of Hubble's new instruments now correct the optics automatically.
This one feels like it won't sit flush on the plate.
What kind of curves do you think Hubble will throw at you? I don't know. It's been Dave surprises each day.
Maybe no more away, right only.
The most challenging fix of all was to Hubble's advanced camera for surveys. Since it was installed in 2002, the ACS had created some of Hubble's most spectacular images.
Takes a few more turns to get it
But
out
a
of
short
the-
circuit knocked out the camera after 5 productive years. Now astronauts would try to get it back.
Turn 1 is out. Nice. I heard that. Thank you, great, John. Nice job.
Nice job, Tom.
Incredibly, the repair went without a hitch. The ACS was back online, and with the replacement of batteries and gyroscopes as well as other repairs completed, the Space Telescope was ready to return to work. It was time to say goodbye to Hubble.
Flight controllers off.
Oh, baby, look at that.
What a beautiful spaceship we're on, guys. It's a real privilege to get to see what we're seeing and get to work on this magnificent machine. Hubble isn't just a satellite. It's about humanity's quest for knowledge. As Arthur C. Clarke says, the only way of finding the limits of the possible is by going beyond them into the impossible.
No one would ever see the Hubble this close again. What astronomers would see through the Hubble's new and improved cameras was yet to come. Like a dandelion adrift in a field of stars, a small, cloudy patch of light in the southern constellation Centaurus draws the eye. This is Omega Centauri. Located some 16,000 light-years from Earth, it is a vast congregation of stars known as a globular cluster. It formed more than 10 billion years ago and now moves through space like a cloud of fireflies as it orbits the center of our Milky Way galaxy. For astronomers, globular clusters are like laboratories, tailor-made for studying the evolution and dynamics of stars. That made Omega Centauri an ideal target for testing the new power of a restored Hubble Space Telescope. In this image, taken soon after Hubble's dramatic repair in May 2009, the telescope's new wide-field camera peers through millions of stars to reveal the cluster's sparkling heart. The stars' dazzling colors offer a clue to their history. As expected, most are yellow or red, indicating these stars are entering their old age after shining for billions of years. But the blue stars, which are much hotter, seem a mystery because blue stars should be very young. Astronomers now suspect some of these blue stars are the result of stellar collisions and mergers. The amazing clarity with which Hubble can view these stars also gives astronomers a window into the future. By comparing this image with earlier images of Omega Centauri, Hubble can see that the stars have moved. And by extrapolating those motions, astronomers can simulate a 10,000-year timeline, showing how the stars will migrate as each follows its own course. Since Hubble was first launched, one of its great achievements has been to reveal in stunning and colorful detail the complex cycle of life and death among stars. Now, with its new wide-field camera in place, Hubble is showing us this process as never before. Here we see in the death of a single star a celestial metamorphosis. Its energy spent, the star has blown off its outer layers, forming what looks like a cosmic butterfly. The details in this image reveal that stellar death is a multi-stage process, with gas ejected at different times and at different speeds to form a remarkably complex shape. The details are important because the material ejected by dying stars is ultimately what will be recycled into new stars and new solar systems, including some with planets capable of developing and supporting life. Elsewhere, in the Carina Nebula, Hubble spies the fiery formation of new suns inside a vast and churning cloud of interstellar gas and dust. 7,500 light-years away, this is one of the brightest and most spectacular star-forming regions in our neck of the Milky Way galaxy. As Hubble zooms in, a blazing tapestry of glowing gas gives way to a more detailed look at a single pillar of dust, 3 light-years long, nestled within the nebula. Powerful stellar winds are gradually eroding the pillar, which acts as a cocoon, protecting a cache of newly formed stars and planets within. With its infrared capability, Hubble's wide-field camera can peer inside the Carina Nebula and reveal hidden details. Here, the infrared view reveals high-speed jets of ionized gas, which point back to a newborn star within the cloud. The jets are a telltale sign of stellar birth, and they signal the arrival of a new solar system on the cosmic stage. Peering out at the Large Magellanic Cloud, a companion galaxy that orbits the Milky Way, Hubble can see the entire pageant of stellar birth and death in one image. This is the Tarantula Nebula, one of the most active star-forming regions found anywhere in space. Here, a cluster of freshly minted blue supergiant stars light up a vast complex of interstellar gas with their intense energy. Many of these stars are burning so ferociously, they will one day be gone as quickly as they came, exploding as supernovas bright enough to be seen on Earth without a telescope. In the process, they will cook the matter in their cores, spewing out the heaviest elements in nature like iron, nickel, gold, and silver, enriching the Large Magellanic Cloud with the same kinds of atoms that, in our galaxy, have been crucial to the development of civilization. With its improved powers of perception, the Hubble has again become the best way for astronomers to trace the ebb and flow of atoms in our own galaxy. But what Hubble is ideally built to do is tell us a story on a grander scale, the birth of the galaxies. That's why, once Hubble's vision was restored, astronomers were keen to point the telescope out to the farthest reaches of space. Before the Hubble, the youthful days of our universe were off limits to astronomers. Of course, it's possible to look back in time simply by peering far off into space. Because the light from distant galaxies needs time to reach us, we can see those objects not as they are today, but as they once were long ago. The trouble is, even looking at galaxies that are millions of light years away isn't enough to see what the universe was like at an earlier stage, when astronomers think most galaxies formed. To do that, a telescope needs to look back about 10 billion light years, and Hubble has been doing just that. Some of the best views of this elusive period come from the Hubble Ultra Deep Field, a sampling of the universe at the very limit of Hubble's perception. To achieve the Ultra Deep Field, Hubble literally spent days staring into empty space. As the extremely faint light of distant galaxies began to build up on Hubble's sensitive detectors, an astonishing picture of the early universe began to emerge. What Hubble found is that at these great distances, galaxies tend to be smaller and more distorted in shape. This tantalizing result means that Hubble is beginning to see back to an era when the galaxies were still forming, mere adolescents on their way to becoming the grand star systems we see today. Since its repair, Hubble has returned to the ultra-deep field and again gone diving into this cosmic well, this time using the infrared capability of the Wide Field Camera 3. The effort has yielded Hubble's most distant finds to date, a handful of tiny galaxies that appear to be a staggering 13 billion light years away. This not only breaks a record, it tells astronomers that the earliest galaxies must have formed quickly, already springing into existence before the universe was 5% its current age. With this incredible feat, the reborn Hubble Space Telescope has now put us on the threshold of the birth of galaxies, one of the great milestones of cosmic history. To actually see the galaxies being born, astronomers know they'll have to go one step further, and another space telescope will have to get them there. Currently, the James Webb Space Telescope, Hubble's direct successor, is scheduled for launch in 2018. By then, Hubble will have finished its long and incredibly successful mission. Rarely has one instrument done so much to change our understanding of the universe. With its newly restored and improved eye on the cosmos, Hubble is not only becoming a legend in its own time, it's setting the course for the next era of cosmic discovery. It has been more than 4 centuries since human eyes first gazed at the heavens through a telescope. Since then, the telescope has transformed our understanding so deeply It is almost as though the universe itself has changed before our eyes. The wandering planets, once no more than bright lights in the sky, have become entire worlds, each with its own unique features. Faint patches of light have morphed into spectacular nebulas, where new solar systems are born by the thousands. Or giant galaxies gracefully flying through the cosmos, millions of light years in the distance. The universe itself has proved to be far larger and more ancient than our ancestors ever imagined. In this century, two questions have set the course for our telescopic exploration of the universe. The first is about the origins of the universe itself. How did all of this get here? And what are the conditions that allowed the universe to evolve from an initial explosive event, known as the Big Bang, into its present form, with stars, galaxies, black holes, dark matter, and more. The second question has to do with our own origins and whether the conditions that led to our emergence here on Earth are common enough elsewhere in space to allow us to find other worlds harboring civilizations like our own. The tools that will allow astronomers to get at these questions are nothing short of extraordinary. They are telescopes, but telescopes larger and more penetrating than any ever built. Some will be built on Earth. Others will orbit in space. Together, they will allow us to see farther than humans have ever seen before. To understand how, consider the Hubble Space Telescope, currently astronomers' state-of-the-art instrument for exploring the universe. The Hubble is really a sophisticated light catcher. It uses its giant primary mirror to grab as much light as it can from distant objects and then focuses that light to produce an image. Looking far beyond the stars of our own galaxy, Hubble's big mirror catches enough light to see very faint galaxies billions of light years away. But galaxies quickly become fainter and are invisible to Hubble beyond this point. So to see more and see farther, astronomers are developing the James Webb Space Telescope. This is a light catcher par excellence, with a primary mirror that covers 6 times the surface area of Hubble's. Any telescope that big is certain to take astronomy to a new level. But getting such a giant into orbit is no small feat. For starters, it's already too big for any rocket to carry. That's why, instead of a single primary mirror like Hubble, the James Webb Space Telescope will use 18 smaller, precisely aligned mirrors that will connect together like a honeycomb after the telescope is launched. These smaller mirrors are also easier to produce and lighter to carry into space. But size alone is not enough. Even with a big mirror like this, the universe makes the most distant galaxies nearly impossible to see. This is because the expansion of the universe pulls the galaxies away from us and shifts their light toward the red end of the spectrum. The very farthest galaxies have been shifted so much they shine not in visible light, but in the infrared. So, to have a hope of seeing even further than Hubble, the James Webb Space Telescope will be tuned to see the heavens in infrared light. This is perfect for observing the distant universe. And it has to be perfect. Because unlike the Hubble, which is much closer to Earth, the James Webb Space Telescope will be too far away for astronauts to reach. That means the telescope will have to work all on its own, with no hope of repair if something goes wrong. Technicians are carefully assembling the telescope. When it's ready, it will be folded up like an elaborate umbrella and launched into space. After a month-long journey, the telescope will unfurl. Slowly and methodically, the various components will unpack themselves. The sunshade will unroll, and the solar panels, much larger than Hubble's, to compensate for a more distant and weaker sun, will deploy. Finally, the gold-coated segments of the mirror array will open like the petals of a flower and click into place, ready to direct light into the telescope's detectors. All that will be left to do then is to look and let the universe reveal itself. The launch of this ambitious telescope will be a major achievement, but it will only herald the start of a new era. To see where that era will lead us next, our quest for bigger and even better telescopes will bring us back down to Earth. Perched on lonely mountaintops in distant corners of the globe, the world's great astronomical observatories seem to exist between two realities: the terrestrial and the celestial. The largest observatories are finely honed operations, more like astronomy factories than lonely outposts. They use sophisticated optical techniques to help cancel out the effects of Earth's atmosphere. As a result, the biggest telescopes on Earth have come to complement and rival the Hubble telescope in space. But now astronomers have come to the limits of what the largest observatories on Earth can see. To see the birth of the galaxies and to look for planets forming around other stars, the next generation of telescopes must be larger, far larger than anything ever built. Today, 3 projects are leading the way, setting the stage for the next wave of great observatories. Each has its own unique design and location, but all will be built to address the same underlying need: collecting as much light from the distant universe as possible. This is a technical challenge of the highest order. For the giant Magellan telescope, the answer is to combine 7 of the largest mirrors possible and hold them together so they can operate as one single supermirror, 24.5 meters across. Like an alien flower, the giant Magellan telescope will turn its petals skyward to gather starlight from the summit of Las Campanas, a spectacular mountain location in Chile. The estimated cost is $700 million. Pushing the limits even farther, a consortium of nations is planning the TMT, the 30-meter telescope. At a cost of $1 billion, it will be built on Mauna Kea and dwarf the other large telescopes that already crowd Hawaii's tallest mountain. Unlike the giant Magellan telescope, the TMT will not consist of a few large mirrors working together. Instead, following from the design of the nearby Keck telescope, it will view the heavens with a mosaic of 492 mirror segments, each just over a meter across. So equipped, TMT will be able to pursue its key goal of investigating the early universe. From the birth of the first stars to the formation of the galaxies. An even larger telescope is now being planned by the European Southern Observatory in Chile. It's called the EELT, short for European Extremely Large Telescope. Like TMT, it will also use a segmented mirror, but in this case made up of nearly 1,000 individual segments, all fitting together to create a light-gathering surface that is a whopping 42 meters across. At an estimated cost of $1.4 billion, this would be, by far, the largest telescope ever constructed. It will be located on Cerro Armazones, one of the most promising locations in Chile, and perhaps the best mountain in the world that does not yet have a major observatory on it. But the EELT will far exceed previous telescopes in its ability to see the early universe. Its instruments will also specialize in identifying the signatures of different chemical elements, helping to identify the ingredients from which the first stars and galaxies were made. As well as look for signs of molecules important for life in the atmospheres of planets around other stars. All 3 of the new giant telescopes could be in operation by 2020, though this will depend on funding. The plan is they will work together with and follow up on discoveries made by the James Webb Space Telescope. They will also be engineering and scientific marvels, monuments to our innate desire to learn about the universe around us. But above all, they will be doorways to future understanding. The tools that will help us discern hidden clues to the nature of the universe and the riddle of life, and point the way forward into the infinite unknown. The next generation of telescopes, both on Earth and in space, promise to help answer 2 of the most important questions we have ever asked about the universe. Where did all of this come from? And are we alone? These questions are not new. What is new are two surprising finds that suggest exciting answers may lie just out of the reach of current technology. These findings are now helping fuel the push for new instruments of astonishing size and ambition. The first surprise is the discovery of dark energy, a term that astronomers have coined for something they barely understand. Simply put, dark energy is a property of space itself. It seems to exist everywhere, and yet cannot be measured directly anywhere. It was discovered by looking at a type of supernova, a brilliant explosion that is triggered when a massive star starts pouring vast quantities of hot gas onto a small, dense companion known as a white dwarf. Once the burden on the white dwarf reaches a critical limit, it becomes unstable and suddenly erupts, generating enough light to outshine an entire galaxy. Then, by comparing both the motions and the distances of many supernovas, astronomers can see if the expansion of the universe has changed over time. When researchers first started doing this in the 1990s, they made an astounding discovery. The expansion of the universe is speeding up. That means most of the galaxies we observe are moving away from us and from each other faster and faster as time goes on. Something is causing this to happen, and that something is dark energy. One new telescope is ideally configured to probe this mystery. It's called the Large Synoptic Survey Telescope, or LSST. While it's not as large as some of the other future telescopes currently on the drawing board, the LSST will have the largest field of view of any telescope its size. Specially designed for a wide-angle perspective, it will take in vast swaths of the heavens all at once, managing to image the entire sky twice every week. All of this data will allow astronomers to look for and measure the effects of dark energy in multiple ways. Those measurements will help distinguish between different theories for what dark energy is and how it works. Theories that can eventually be tested by the much larger telescopes to come. The other question motivating the development of new telescopes is one that goes to the very heart of our existence. We know, because we are here, that life is possible. What we don't know is how likely life might be, and whether the odds favor us eventually making contact with other civilizations on distant worlds. One way to address that question is to find other places in the galaxy where life could be. That's why the discovery in the 1990s of planets orbiting nearby stars electrified astronomy and captured the public's imagination. So far, none of these planets share exactly the characteristics of Earth, including size, composition, and temperature. But NASA's Kepler spacecraft, currently in orbit, is capable of detecting other Earths, and when it does, larger telescopes will be needed to follow up. astronomers are now considering how best to create a new kind of orbiting space telescope that will be able to zoom in on the other Earths that Kepler finds. To succeed, such a telescope will likely be both large and complex. Its job will be to tease out the faint light of an Earth-like planet from the billion times brighter light of the star it orbits. If it succeeds, that light can then be analyzed for signs that there are biologically important molecules in the planet's atmosphere, like oxygen or water. Just a generation ago, astronomers would have thought such a feat virtually impossible, but it may only be a decade or two away. In the end, it is our curiosity about ourselves and our desire to find others like us that will drive the development of telescopes to even greater heights. With the telescopes of the future extending our vision even farther into the cosmos, it seems there is no end to what we may see.